we're going to look at projectile motion. So projectile motion is when we're looking at an object that has been thrown or launched or something like that. So we're going to make some assumptions about projectile motion. The first is that air resistance is ignored. So the air resistance is not going to slow our object. We're also going to ignore the effect of the rotation of the Earth. The second effect is pretty tiny, but I guess it does have an effect. What that means is that when we are considering a ball flying through the air, the only acceleration that is happening to the ball is the acceleration of gravity. So as gravity is pulling our object straight down, and that's it. That means that projectile motion becomes a pretty solvable problem, because we want to look at the motion in the x direction and the motion in the y direction. So in the y direction, you've done this problem a bunch of times now, right? You throw the ball up in the air, how fast is it going after how many seconds, or the reverse where it's dropped. If we look in the x direction, here it's even easier. There's no acceleration. The only acceleration is straight down, so the motion in the x direction in a free fall problem is constant velocity. If you want, you can just imagine that we have one person standing exactly in the path of the throw, and he sees just the ball going up and down, and they're going to see a motion that looks like a one-dimensional motion, with gravity accelerating the ball down. A second person can be up in a blimp, and they can sort of see the ball travel to the right, and then they're just going to see the ball travel with constant velocity. You also want to remember, if we are given an initial velocity at some angle, then we can use our vector components to find the initial velocity. So the x component of our initial velocity is going to be that initial velocity times cosine theta, and then the y component here is going to be the initial velocity times the sine of theta. So to show this concept, here's a photograph showing how this works. Two balls are dropped, and the strobe light is used so you can see where the two balls are at each point in time. So this is like the motion diagrams that we did earlier. So the point is that both balls are released at exactly the same time, with the red ball just being released, but the yellow ball has rolled off of the table at exactly the same time, so it is moving to the right. The key is that the time it takes for the two balls to hit the floor is exactly the same. Because their initial velocity in the y direction, up and down, is 0, they both start with a y velocity of 0, and after a second they're both going negative 10 meters per second, and after 2 they're both going negative 20 meters per second. You can also see that the yellow ball is moving to the right with constant velocity. So another way of saying that is gravity doesn't care that the ball is moving to the right. Gravity accelerates everything by 10 meters per second squared, straight down, and that means gravity only cares about that motion in the y direction. Okay, so let's look at a general example here. So we're dropping a care package from an airplane, and so the plane is traveling to the right at a velocity v, and the package is dropped. That means that the initial velocity is in the x direction, and it's the velocity of the plane, and the velocity in the y direction is 0. So you're going to see a number of problems like this one in homework and in classwork. Usually, though, it will be like a thrown object, or maybe we're firing a cannon, but the basic concept is all the same idea. So as it drops, the velocity in the x direction will remain constant. So it's v naught at the beginning, that velocity of the plane, and it's going to be the velocity of the plane at the end. And the reason for this is that there's no acceleration in the x direction. For y, it's the same question you did before. The box drops a certain distance, then we can find the time if we know the height. So the general method is to find the y component to find the time in the air, or perhaps time to apex, and then we use that time to find out how far it traveled, because the motion in the x direction is constant velocity, so we multiply the velocity by time. Okay, so in our example here, our plane is traveling 120 meters per second to the right, and it's flying at a height of 500 meters. So that means the care package needs to be displaced by 500 meters in the y direction to hit the ground. So to solve this, we do exactly what we did with the helicopter problem that we did a week or so ago. The initial velocity in the y direction is 0, so the question is how long does it take for this to hit the ground? So we write down our sort of standard kinematic equation here. So y is equal to v naught in the y direction times time minus 1/2 gt squared. Notice I changed the acceleration to be g, since that's what it will be for your free fall problems. So to do this, we can solve for time because velocity naught is 0. So that means then y is equal to just minus 1/2 gt squared. And so now, since we've got g and we've got y, that's the negative 500. G is 10 meters per second squared. So we can just rearrange this and then solve for time, which we will find to be 10 seconds. Now we switch to the x direction, and here we know that the velocity is in the x direction is 120 meters per second. We know that it's flying in the air for 10 seconds, our answer from the previous one. So we can just plug that in. So 120 meters per second times 10 seconds. So we get a distance of 1,200 meters. The key is the velocity isn't changing, so the initial velocity is the average velocity. The key is to focus on the y direction first to find out how long our object is in the air. Then we multiply the time in the air by the velocity, since it's not changing, since there's no acceleration in the x direction. Yeah, we can do more complex things with this question, but I think for right now, we'll just focus on range problems. Okay, so we'll do one more, and then you'll do a few. In this one, a ball is thrown at 20 meters per second horizontally, so it's all in the x direction, and it starts at a height of 20 meters. So our first question is, how long does it take for the ball to hit the ground? The question is asking us how many seconds it takes for the ball to hit the ground. So that depends on the y direction. So we write down our kinematic equation for the y direction. So delta y is equal to the v naught y times time plus 1/2 acceleration in the y direction times time squared. Notice I'm only looking at the y direction here, so the initial velocity in the y direction is 0. So that means we can just plug this in. The displacement here is negative 20 meters from the window to the ground, and then our acceleration is negative 10. So we can do a little algebra, right? Multiply by 2 divided by negative 10, and then solve for t. And so we find that it takes 2 seconds for our ball to hit the ground. Now we want to know the range. How far did the ball go? Well, it is traveling 20 meters per second for 2 seconds, so we can find that pretty easily. So we'll plug in our general kinematic equation, but acceleration in the x direction is 0, so that means delta x is just the initial velocity in the x direction times time, and so that initial velocity is 20 meters per second times 2 seconds, so that gives us our 40 meters. The idea is that we're breaking our problem into 2 pretty simple problems, so while it seems like moving to 2D is a lot, we're really just doing the same thing we were doing before, we're just doing it twice. Alright, so I think that's enough for this class. So you have a few questions to answer, and so good luck with that, and take care of yourself.